First of all, I'm very happy to be here. I'm very sorry that we have still some challenges with the techniques. I somehow missed the tech check, so it's somewhat also my fault, so don't blame those guys here. They're doing a great job. And what I want to do today is I want to answer with you the question if we should forget about AUTOSAR, because you saw automotive towards SDV. It's like we're all charging toward that promising land of SDV. Now, should we now throw away everything we did in the past into the bin and forget about it? And this is a little bit what I want to talk with you today and want to give you some insights. So first of all, thank you, and a short round of applause for the technicians for helping me out here. So I want to bore you with some introductory slides just to show where we currently stand with the AUTOSAR organization in the market. So here you can show some of the biggest OEMs worldwide, split to the revenue, and which of those are using AUTOSAR as their base technology. And as you can see, most of them do. Secondly, also over the last years, we have had an increased engagement of companies with the AUTOSAR technology in general. So we're talking about more than 360 companies today, which are AUTOSAR partners. Then we can also have a look in the regional footprint. As you can see here, Europe is very strong with respect to AUTOSAR, but 2 years ago, Asia overtook Europe. So there are more companies involved in AUTOSAR technologies in the Asian market than in the European market. And looking at it, this is a very common slide in the automotive industry, I would say. We have had an evolution of technology in the automotive industry, starting from software only for single-purpose, single-use use, like powertrain control units or like HMIs, and expanding to linked networks. That was basically when AUTOSAR was founded in 2003, where we tried to fix this integration hell, first time in the automotive industry with the linked networks, where we wanted to have the ECUs better talk to each other. In the meantime, there have been several steps of development. For example, most of the technologies we've seen that changed the AUTOSAR standards were mainly driven by EE architecture changes. Secondly, there was a direction towards a centralized compute and towards domain centralization, and the next step is introduction of the zone architecture. And the thing that we are all talking about since 3 years is software-defined vehicle, which is most likely built based on a zone architecture. And what that means for AUTOSAR, this is what I want to talk to you about, so how we interpret it, to further digest whether we can forget about it or not. So first of all, the SDV understanding is we are changing from a hardware-based, very static approach to software-centric dynamic approach. We are introducing new features and new services during lifetime of the vehicle. We want to have software-driven platform approaches across different car lines, across models, and across also different development years. And obviously also we want to be quicker if there's any incident in the field to get rid of it. Bug fixing, also identifying if there are any issues with it. Then obviously extending of the life cycle of a vehicle. Today, the vehicle has its most value when you buy it at the dealership. From there on, it's only degrading. In the future, we also want, in the automotive industry and the SDV, to provide additional value to the customer with the vehicle also being in the field, by keeping it up to date, by also keeping it secure and safe. Then last but one of the next steps is everybody of us has smartphones, has a digital world, a digital experience he's engaged with. And everybody of us is dreaming about taking this digital experience also in their mobility experience, like, for example, the vehicle they're renting, the vehicle they're driving, vehicles they are leasing, and maybe also vehicles they're lending from their parents or from their other spouse or whatever. And this brings us to opportunities for a lot of new relationships and business between OEMs and different tiers of suppliers, and also users of the vehicle, and many, many more. Now, these are all of the promises. So how can we tackle that? And there is kind of a logical view that's not really an architecture. It's not really, however you want to call it, we call it logical view, a technology map. But there are certain aspects that will play an important role with respect to SDV. So at the left side, we see everything that has to do with the in-vehicle software. We have hardware platforms, hardware abstraction APIs running on top of them. We have execution environments. We have also platform services. They but not only stay in the hardware, but also expand to the right side of the software, which is the cloud side of the software. And this is very important because at the end of the day, we will see software running in the car that has to do with your experience, also software running in the cloud. And additionally, and some of you have already seen that, a lot of Eclipse presentations is that the tool chain, the DevOps approach will also play an important role. So this is the picture we have. That doesn't mean AUTOSAR wants to cover that all. As you've been, maybe some of you have been in the SDV Alliance panel discussion, you see that we are collaborating. So our focus is mainly on this in-vehicle execution environment and making things compatible with the pillars around us in the SDV world. Looking at it from a vehicle perspective, here you can see how such a vehicle can look like in a software-defined vehicle. In the middle, in the orange part, you have the HPCs, so the number crunchers of the future with all of the performance to execute cognitive functions in the vehicle. Then around it, you have, oh, that's an animated slide, so you can't see anything. That's my bad. In the middle, you have these HPCs. They're usually connected via Ethernet, and they're talking via service-oriented communication to each other. They will do the main calculation in the vehicle. Then, as next, you have the zone ECUs, which are also connected via the same high-speed bus to the HPCs. And obviously, at the end of the zones, you have the sensors and actuators. May it be smart actuators which run own software, or may it be really, really simple actuators. And sensors, obviously. Now, basically, a lot of those things will host AUTOSAR technology in our understanding. And which one of those I will go further into detail in the next slide. So you're not missing anything by going to the next step. The first thing, forget about AUTOSAR, question mark I want to tackle is something which we have just started, which is basically the vehicle, the Automotive API. The Automotive API is in collaboration with COVESA. So we have different use cases we want here to fulfill. So we want to introduce a standardized way to access indirectly the vehicle data. So you have different use cases like a vehicle user, a non-automotive service provider, an automotive service provider to directly or via a gateway indirectly accessing data from the vehicle. And this is, in our opinion, a very central element of the software-defined vehicle. And technological-wise, we are trying to solve that with the following building blocks. So we are, as mentioned before, here we are collaborating with COVESA. COVESA has with the VSS a semantic catalog describing certain properties of the vehicle and exposing it to the cloud. Secondly, also COVESA has, together with W3C, developed a specification for payload serialization, deserialization, named VISS. And thirdly, in AUTOSAR, we know how to describe the communication within the vehicle network, for example, via SAM-IP or via DDS. And here is basically where together we want to bridge these two worlds. And this year there will be a first release in AUTOSAR 2411, where we have the first artifacts of this collaboration between COVESA and AUTOSAR released. Next, let's have a look at our platforms. So we talked about the HPCs. So the question is, what's going to be AUTOSAR Adaptive's role in the SDV? And here you can see AUTOSAR Adaptive from its original thought process has been built for the central computers, right? As you see here, this is basically also running most likely, and also today what we see in the field, on a hypervisor, yeah, which also allows other partitions next to it to be executed. When we come to AUTOSAR Classic afterwards, you will also see that the same ECUs will host AUTOSAR Classic for safety-critical real-time cores. And what is AUTOSAR Adaptive providing there? Here you can see the AUTOSAR Adaptive architecture. It's basically a lot of building blocks. It's not a layered architecture like AUTOSAR Classic, so each of the building blocks itself has an exposing API to the application, and goes down to the operating system. And this it looks very much like a lot of other architectures outside. So I want to give you 3 views to this architecture on top. The first view is, what kind of automotive protocols does AUTOSAR support? Because at the end of the day, AUTOSAR itself is not just about an abstraction for communication, but also implementing a lot of core automotive features. As we can see here, a lot of them are mentioned on the slide. They are also then supported in the architecture, in the methodology, and the processes of AUTOSAR Adaptive. Second view, security support. We have a lot of security support in the meantime with firewall concept, the SecOC, TLS, IPsec, MACsec, secure storage, trusted platform, authentic logging, and so on, to also support the creation of secure systems based on the AUTOSAR Adaptive platform. And last but not least, coming back to Dana's presentation, of course, also safety. Sorry about that. There are a lot of building blocks also that support safety concepts. As you know, safety is a functional property, so you cannot implement it out of the box, but you can reuse certain building blocks for similar functional decompositions in your ECUs and in your vehicle. Now, to summarize it, AUTOSAR Adaptive is key to be deployed on HPCs. It's an important part of the HPC full stack. It provides access to automotive specific functions, enables functional safety, and is designed also to be compatible with AUTOSAR Classic. Talking about AUTOSAR Classic. This is basically, again, our picture from before. And on the next animation slide, we will see the kind of issues we are anticipating the AUTOSAR Classic platform being used for. And AUTOSAR Classic is now, in the meantime, not the youngest child any longer in the block. So it has been starting of AUTOSAR basically. And this layered architecture, real-time capable for microcontrollers, which has constantly evolved over the years with the evolvement technologies around microcontrollers in general. And main purpose of AUTOSAR Classic is basically hardware abstraction, scheduling via an OS. It's communication, diagnostic, functional safety, and security. As you see, both of the platforms have the same properties that they are tackling. And this is also very important because at the end we want to build reliable systems in the automotive industry. So, as mentioned, it's targeted mainly for deeply embedded ECUs, safety critical functionality up to ASLD, with hard real-time capabilities, designed mainly for microcontroller architectures. It's designed for smaller footprints, and it's designed for signal-based communication. Of course, it is made compatible with some IP to the service domain, but it's not natively supporting service domains like other POSIX-based architectures are doing. Now, also, AUTOSAR has the reputation of being quite old-fashioned and closed. And we have started a while ago the opening strategy, and we have concluded now several steps. So we have increased our presence in the regions. We have local spokesperson. We are also all struggling with having local contacts in the very European-driven consortia. We are also collaborating with third parties to make it easier that things work together, as you have seen with the Alliance, also as you have seen with the collaboration with COVESA. We have introduced ways also for premium partners to have more influence on AUTOSAR with the Premium Partner Plus program. We have also created whitelist of derived application where you can also use AUTOSAR for. We have also introduced something that is called Associate Partner Lite, which gives an easier access to the AUTOSAR work for compatibilities topics. And we have started the Automotive API with COVESA. What we are still working on is the AUTOSAR Open Framework. And this is basically where we want to enable a collaboration in an SDV ecosystem. And goal is here to be able to also have software implementations and to collaborate also beyond what our rules are today in the AUTOSAR contract. And it should be open for interested parties, being AUTOSAR members or non-AUTOSAR members. Very important. This should not be a competition to Eclipse. This is only for topics that are very close to the AUTOSAR standard itself. It should also be a competition to Linux Foundation or other foundations. So really where the core technology is around AUTOSAR. Having said that, we are trying to launch, and we plan to launch something, and this is also stimulated by the discussions around SDV core stack and opening. We try to launch or plan to launch a so-called AUTOSAR adaptive implementation. And we want to collaborate here with Eclipse and also with all of the stakeholders to implement according open source principles, to also align the processes, what are the expectations with the companies behind the Eclipse core stack. We also want to introduce an AUTOSAR open license where collaboration will be possible, also for non-AUTOSAR partners. And we are very, very happy to get your feedback, to get your discussion, as I think it will be very important that we start to collaborate more in the open. And this has been very difficult in the past years, but we have looked into a lot of new approaches, and we think we have thought a concept that will work, and this is why we are announcing this today. And we would be very happy if this will be successful. Then, what is AUTOSAR's goals for SDV? We want to support, we have 370 partners, we want to support the automotive industry in the transformation to the SDV. It's not our topic. We are one piece of many pieces, so collaboration will be key in the industry. And obviously, we want to take what the automotive industry has built in the last years from a technology in AUTOSAR Classic and Adaptive, and also retain it in the future, the next generations. So looking at it, Automotive API is to connect the vehicle to the cloud. Classic platform is a reliable, dependable platform. Adaptive is high-performance computers, also featuring safety and security requirements. We're evolving the AUTOSAR organization to be more open, and we want to collaborate in the open, or want to enable companies to collaborate in the open on an AUTOSAR adaptive implementation. So in our view, AUTOSAR will be one piece of the SDV, and we are really happy to build that together with you. With that, thank you very much for your attention, and I hope I was lightning fast enough. Thanks a lot.
Thank you, Michael. Yeah. Do we have time for questions, or are there any questions? Steve, hold on.
I just wanted to know what open really means, because in our sense, with Eclipse, open means you see the code, you can talk about the code, and everybody can contribute to the code. You can use it, you can productize it, you can develop it. What does open really mean, or what does AUTOSAR envision open to really mean?
So that is a very good question, Steve, and I really appreciate that you asked that. Yeah. So we want to enable all of the collaboration model in the code creation process, right? So open to AUTOSAR members, open to non-AUTOSAR members, open code, governed by a license. Yeah. And as you have seen maybe on this slide, this license is basically giving you all of the copyrights that we are planning to do, but it's not able to give you the IP rights because AUTOSAR as a GBR doesn't have the intellectual property rights. They are with the partners. So we're using open source-based licenses that already exist that follow such of those classes, and will extend it accordingly to also provide the user of the license a hint to have for IP problems the chance to join AUTOSAR, because between the AUTOSAR partners there's a non-assertion agreement, so less risk to be pulled into an IP infringement in the usage of this source code. Yeah. So it's not something very specific to AUTOSAR, it's standard open source license-based, which are also existing with respect to limitation of IP rights if you don't have them for sure available, like Apache 2.0, like Fraunhofer license, and those. We are looking into to create that. Yeah. Does it answer your question? So we want to have CLA, charter document, collaboration between all of the partners in the open, so not hidden behind a wall. And this is basically what we are planning to do. There are still some assessments to be done on the legal side, so we have some confirmation for Germany and Europe, but we also need to check other regions accordingly. Yeah.
So this will finally enable the Open SDV Alliance to be able to use AUTOSAR code to put together software for demos and so on. But
yes.
No one can take that code. Well, they could take the code and put it in a commercial viable product. They just have to deal with the potential consequences of the patents.
Yes, on their own, yeah. Which could mean lowest risk is joining AUTOSAR. Okay. Other risks are, but this is a general risk with open source using, for example, Apache license. You always need to take care about the IP and patents topics on your own, right? Because you're not automatically getting them.
Okay. It seems to spark further.
Follow-up. Will this take care of the dreaded Eclipse Summer problem?
I hope so. The intention is yes.
Me too. But
we need to also exchange, obviously, with Eclipse Foundation and other colleagues whether such a license is acceptable. Yeah. But if this license is acceptable, they should take care about that, and also about all of the other contribution related to AUTOSAR IP. That's why we're doing that. Yeah.
I'm not really sure if we're talking about the same thing. I'm talking about being able to actually use Eclipse Summer under the intended Apache license.
Under the license, we will have to see. Yeah. I cannot answer that by heart. We will have to look into that. But the intention would be that collaboration with an open license in the open should be possible with that. Yeah. I'm not giving any guarantees here.
For the usage part of it, yeah. That was my understanding of what you said earlier.
For the collaboration part of it.
No, I mean,
yeah.
I can use it for demos. I can take a look at the code. It's just I cannot use it in a commercial product.
You can if you take care about the IP situation.
If I'm an AUTOSAR member, yeah. Okay.
Compared to an IP assessment, it is relatively small effort. Yeah.
Okay, I mean, that's apparently a hot topic.
Yeah.
If there are further questions, I think we can cover it later. But I'm also involved in that discussion. I mean, there's a constructional setup of AUTOSAR that's very difficult to rectify 20 years later.
Yeah.
But I appreciate that Michael and the team are working hard to get the best possible solutions out of that. And at least during the last 2 years, we have moved more than in the 20 before.
Or let's say since the announcement, the last 4 months, there was a lot of progress in this direction, right? So that gives us, so I'm a little bit personally, I'm a little bit thankful for that, so that we get some momentum in there. And I'm looking forward to conclude this within the next, hopefully this year, latest, hopefully first quarter next year. So this is what we're really trying to do, solve as soon as possible.
So open sourcing the automotive cloud seems to be a very ambitious goal. So yeah, can you please shed some light what's behind and to what extent you are already able to open source the automotive cloud?
Sure. Am I audible now? Yes.
Yep.
So perfect.
Yes, we see the slides. Not the
there
presentation.
we have something. Yeah. So let's do like that, and we have it the right way. Perfect. So yes, the automotive cloud. So I think we spent the whole day talking about things that's not in the cloud. Basically, I've seen it in a couple of slides, but it's been mostly focused on in-vehicle stuff so far. So where do we want to go with this? So first of all, my name is Thomas Karlfark. I'm CTO at Wireless Car. What I've been doing for the past 20 or so years is building connected car services for a number of different brands, more or less. So it is work, of course, to do that, but it's my passion to build stuff in the cloud for cars, basically. But now the cloud is extending into the car, so it's sort of getting mixed. So what is it that we want to do? So we want to revolutionize the connected vehicle cloud services, basically through the open source movement. So we're in the beginning of the software-defined era, I would say, in the industry, and it will impact everything, how we design, build, and interact with vehicles. And as in other industries, open source has been a game changer there. So can it also be that to drive innovation and improvements also in the automotive technology? I definitely think so. So it will enable us to collaborate and innovate and bring solutions to the market a lot faster than we have been able to do before. And at Wireless Car, we've been dedicated to enhance the connected vehicle experience for the past 25 years. And with that history that we have to deliver cutting-edge cloud services, we think that we know quite well the challenges that is in front of the whole industry now. So we think that we can help with this transformation. And we do recognize the large potential of using open source, so we're really excited to introduce our idea, it's still an idea, to establish an open platform for connected vehicle cloud services that is tailored specifically for the SDV landscape. So it has been mentioned, I think, in every talk so far today, what is an SDV? I'm going to repeat it with our definition or a very brief definition. But to me, it's basically, to the very simplest definition, it's a vehicle where software enables the most of its functionality. It's a shift where the vehicle becomes more flexible, updatable, and personalized than we have seen before. The drivers behind this, of course, as you know, the digital transformation of the vehicle industry, the automotive industry. The vehicles are no longer just mechanical devices. They're becoming sophisticated digital products, basically. And with that, the consumers, they expect that the cars are as updatable as the smartphones. They will want features and improvements delivered regularly through the software updates. And then additionally, the technology advancements that we see all over the place, they're making it possible to increase or enhance the vehicle functionality over time with software. But with this comes a lot of challenges, as we all know. That's what we're talking about here. I mean, to develop these and to maintain these complex software systems requires a lot of effort and a lot of resources and expertise. And then in addition, since the vehicles are becoming more connected, more updatable, there is a security concern with targeting. They become more of a target for cyber attacks. Then, of course, there are opportunities, as we all know. We can do software updates to rapidly fix problems and add new features without doing any hardware changes. And then there's also potential new business models where you can add features and have premium features that customers pay for through software subscriptions. So I think open source can help with both the challenges and the opportunities here. So with the open collaboration that we can do, we can develop shared solutions and we can set standards which will accelerate the innovation in the end. So this brings us a little bit to what we are thinking about at Wireless Car. So I want to show some of those thoughts here. This is an example vehicle cloud architecture. Not very deeply technical, but it's basically what you see in a connected car cloud. And on the left side of this is a number of enabling features, such as vehicle integration things and provisioning services, sim lifecycle management, and those kind of things that are the basics to get a vehicle connected to the cloud or other things. And then to the right, there are some more or less value-adding services. That list can get a lot longer, of course. It can go on forever, basically. But in the end, the status quo right now is that most OEMs, they have at least 2, probably more implementations of a very similar architecture like this. And it's just getting more and more because OEMs tend to create a completely new implementation of a very similar architecture for every vehicle program, or vehicle platform program at least. And then this is kind of matching what's going on the embedded side, right? Because they also create completely new architectures every time. And that's at least what I think that the problem that we're trying to solve with all these open collaboration for us. So we want to do the same for the cloud side. So that's one big driver for us. The other one is actually that we're seeing that the left parts of this picture are getting, or the whole thing is being commoditized basically, but it's starting from the left and moving to the right. So that's the reason we think it's a good case to standardize this using open source. So if we switch that kind of architecture picture into a map of capabilities instead, this is not complete, but it's a lot of capabilities that are needed in a connected vehicle platform, basically, and that's stuff that any OEM must have. And then to clarify, these capabilities, most of them needs a component both onboard and offboard. So our vision is to build an open collaborative ecosystem around this. Then that accelerates the innovation and standardizes the fundamental components of these connected vehicle services, so that we can have interoperable, standardized systems that we can develop once for most of the vehicles out there. And we think the open source way is the right way to do this. And we have an idea where to start. It's indicated in the picture where I've highlighted some of the capabilities that I think should come first. If we start with the digital SIM lifecycle, which then includes the capability to connect the vehicle to the network and manage the SIM profiles during the whole vehicle lifecycle. Then we add data routing, data ingest, vehicle integration, which is the core building blocks, basically, to make the vehicle able to talk to the cloud and other systems. And then the digital twin, or parts of it at least, which includes the replication of the dynamic vehicle data then, and the BOM-like, more stable data that's related to the vehicle. If we have those services, we can build a very large part of the use cases that most OEMs need. And if we can get that standardized and open sourced, I think it's a big benefit to the whole industry, basically. And then if we add on also the digital key management and over there updates to that, then it's a real good fit for the SDV. So our intention is to use our battle-tested software, basically, then to open those code bases up to solve some of these capabilities. We need more. We don't have everything. We have a lot of it, though. And we believe this will lead to better services, more robust services, and more performance solutions in the end. So doing this in the open, I think, is the best way forward. So what is then the benefit of this for the OEMs or the suppliers or the end users? Of course, it's the same as you always see with the open source solutions. It accelerates innovation. You can use the smartness of all of us, all the open source community to bring more advanced features, because then the OEMs can use their resources more effectively and build more advanced features. Then, of course, cost efficiencies are realized here. If you do more shared development, you can use your resources for other things. Standardization and interoperability means that you can connect with vehicles in a much better way than has been done before. And then suppliers, of course, will have greater market opportunities if you all align on the same platform, basically with your value-added services, then you have a greater opportunity there. So I believe that an open platform like this is a catalyst for a positive change, for efficiency, innovation, and satisfaction across the board, basically. So why are we here? We want your feedback, basically, who want to be part of extending the open collaboration also into the cloud to build the open connectivity platform for the SDV. And that was really lightning fast, because now I'm done. One question.
Just handing over the mic to Steve for the first question.
Could you happen to go back one slide? One more? There you go. Okay, so Wireless Car as a company is considering the blue parts to be open source?
That's what I'm considering. That's a starting point.
Okay.
If we can do those, then we have a foundation. In the end, everything needs to be open source. Not needs to be, but it could be.
Has Wireless Car done studies on existing open source projects that are in Eclipse and other COVESA and other?
We're doing it.
Okay.
So I mean, if there are stuff there, we can contribute to that.
So one of the things that Kai and I will talk about tomorrow, but is about adopting an open source culture, and one of the issues is that even though it's encouraged to have many open source projects, we need to converge. And so sometimes the right decision is, rather than coming up with yet another something, is to look at what's already there and contribute to that, which quite a few companies are doing for some projects. I don't want to highlight my project, but just to say that there's quite a lot of convergence happening, and I would hope that Wireless Car wouldn't just dump yet another something and consider. So are you considering the other projects and studying them?
Yeah, for sure. I mean, I don't claim to know all of the projects that are out there. So that's part of our plan as well, to look at that. But we don't want to dump anything, yet another thing there. So then it has to add value.
Yeah, because the Technical Advisory Committee and other committees inside of the Eclipse is trying to work on a distribution, and in order for us to do that, we need to converge on entities that we want in the distribution. So maybe you can contribute there, or also
Absolutely.
talk with a bunch of us.
Yeah.
Will do.
Thank you.
That's exactly the kind of feedback I'm after. To whatever is out there, if you know things that would fit in, then let us know.
Please not yet another orchestrator, please.
Yeah. Holger is in. So the question you may have answered implicitly. So opening up those parts, you consider to do in Eclipse SDV, or?
That's also something we're looking at. Is Eclipse SDV the right place? I mean, what do you say? Our impression is that right now it's a lot focus on the embedded part in the Eclipse SDV, not so much the cloud. I know though that it is part of the charter to include that as well.
The scope is car, cloud, and tooling, so would definitely fit in. And I'm not sure. So the blue part already working on, and that would be the first, or you have available.
That's our current ID, at least. So then.
And that's how you consider.
Then we want to work with the community partners, customers, and to see what's the most valuable to bring out first.
Okay, thank you. Leads me to the next question. Sorry if please raise your hand if I'm stealing your question. So what's the business model from Wireless Car point of view? When open sourcing certain components, what's your part? Where do you, at the end of the day, expect to earn money from?
So it's multiple, but for the platform part, we're thinking permissive licenses like Apache too, and or donating to something like Eclipse, and then we basically the business for us would be to to do consultancy or managed services around that, more or less.
Thanks. Further questions from the community? Yeah. Bernhard.
It's going to be a tough question.
It is hard to read from here, but luckily through my glasses I can read something which is labeled digital twin. So I'm curious, Thomas, that you outline what is your focus, or what do you expect from a digital twin from your perspective?
It's funny because my colleague here, we have a debate on this topic. For me, the digital twin is post-production. When the cars are on the street, all the dynamic data they're generating, sensors, all that data over time, as well as the BOM-like data, like what's included, what software stack is it, and the color of the car and those kind of things. All that is part of the digital twin in this sense.
So it's more like the inventory, what's installed and how it's being configured, and not a virtual software representation of the car. So I think we need nomenclature here as well. More questions? Steve? Okay.
So if you guys do a lot of things in the cloud, do you have your own cloud infrastructure? You use one of the big three? Are you cloud agnostic?
We're using mostly one of the big three at the moment. For this, since a while we're embracing the cloud native computing from CNCF, basically, to be more portable when it comes to clouds.
Yeah. Okay, so you would be agnostic then?
Yes.
Yeah.
Well,
Thank you.
I don't like the word agnostic, though. It's portable, I would say. So.
Portable is better. than
Portable. It's not that trivial. Yeah. All right. One more question from my side. Which solutions or services do you already have out in the field? Can you shed some light there? None, or is there?
We do not have any open source things out there already, but for otherwise the solutions we have is the whole connected car platform according to this, and then all the services, the standard user-facing services that you can see in your companion app for your car, for example, doing remote services. And
these services on closed platform is already out in many vehicles.
In lots of different brands.
Yeah. And the open one, so do you have a rough timeline? By when would you like to be able to publish something on open source?
Sometime next year.
Next year.
Would be the timeline.
All right. Okay.
25.
Good. I think we are at
Time's
the
up.
end of the time. Thanks again to you, Thomas, for your presentation. Thanks for the audience.
Thank you.